Welcome back to this explainer. Today, we're diving straight into Module 2, Cost Concepts and Design Economics. We are going to unlock the secret mechanics of project economics, moving step by step from foundational definitions all the way to advanced profit optimization. If you've ever found yourself wondering exactly how major engineering firms or tech giants price their products and maximize revenue, well, you are absolutely in the right place.
Okay, let's kick things off with a pretty wild number, $412.75. According to the data, that is the estimated production cost of the 64GB iPhone X. Unsurprisingly, the most expensive part of that is the Super Retina display, but the total sum of all the components sits right around that $400 mark.
But here's the question that really drives engineering economics. How does a phone that costs just over $400 to build actually retail for $999? I mean, that's a massive 59% margin. Now, this isn't magic. It's the direct result of mastering cost estimation and design economics. Companies like Apple don't just guess at pricing. They use rigorous economic analysis, and that is exactly what we're decoding today.
Section 1. The Language of Costs, Mastering Vocabulary. To build a highly profitable project, we first have to master this foundational vocabulary. After all, you really can't optimize what you can't properly define.
So, the crucial starting point is knowing the difference between direct costs and indirect costs. Direct costs are expenses you can easily measure and allocate to a specific work activity. Think of the raw materials for that iPhone screen, or the direct labor on the assembly line. Indirect costs, on the other hand, are often called overhead or burden. These are the tricky ones. This would be the electricity required to run the entire factory, or your marketing team. You know you have to pay them, obviously, but tying those costs to one single phone or one specific batch of concrete, that's really difficult.
Now, here is a massive trap a lot of businesses fall into: the sunk cost. By definition, a sunk cost is money that has been spent in the past and has absolutely no relevance to estimates of future cost or revenues. It's money that's already gone. But human psychology makes it incredibly hard to let go of sunk costs, and that naturally leads to some pretty terrible economic decisions. Let's put this into perspective with a quick scenario straight from our source material. Imagine you just blew 2 million ringgit developing a prototype that completely failed its safety tests. But a brand new technology is available that would cost 1.5 million ringgit to implement. Management is dragging their feet because they feel they already invested too much in the first design. So what's the correct economic viewpoint here? If you blow 2 million on a failed prototype, the only correct choice is to ignore it. It's a sunk cost. You cannot blindly push forward just because you've already spent the cash. You have to evaluate that 1.5 million ringgit investment purely on its own future merits.
Alongside sunk costs, you also have to weigh your opportunity cost. This is the monetary advantage foregone due to limited resources. Basically, it's the snappy way of asking yourself, what profitable path am I giving up by choosing this specific route? If you commit your capital to Project A, your opportunity cost is whatever profit you could have made on the best rejected alternative, which we'll call Project B.
Section 2, Fixed versus Variable Costs, the core of cost volume. Let's move to our next building block and see how these two costs dance together in the real world.
Let's break down the two main players. Fixed costs? They stay exactly the same no matter what you do. Whether you produce 0 units or 10,000 units, your monthly rent, your insurance, and your setup costs remain completely unaffected. Variable costs, however, literally vary with your output. Paying hourly labor, hauling materials, buying raw supplies, these are all going to scale up or down depending on exactly how much you produce.
To see this in action, check out this asphalt mixing plant example. A contractor needs to deliver 50,000 cubic yards of paving material and has to choose between two sites. Site B has drastically higher fixed costs. The rent is $7,000 compared to Site A's $2,000, and the setup is a whopping $50,000 compared to Site A's $15,000. But look at the variable cost, the average hauling distance. Site B is only 3 miles from the job, while Site A is 4 miles away. Because hauling costs $2.75 per cubic yard mile, Site B cuts down the hauling distance, meaning its variable costs are much lower. We are directly trading off higher fixed costs for reduced variable costs.
Section 3, Calculating the break-even point. So how do we know if trading those higher fixed costs for lower variable costs is actually worth it? We calculate the break-even volume. And this graph brilliantly illustrates the math. Let's look at Site B. Total fixed costs for rent, setup, and a required flag person come to $90,750.
The variable cost is 3 miles times $2.75, which comes out to $8.25 per cubic yard delivered. Now, the contractor gets paid $12 per cubic yard. By setting total cost, which is $90,750 plus 825x equal to total revenue, which is 12x, we solve for x, and boom, x equals exactly $24,200. This means Site B starts generating pure profit only after 24,200 cubic yards are delivered. Since the job requires 50,000 cubic yards, Site B clears the break-even point with plenty of room to spare.
Section 4, maximizing revenue and profit. Because once you clear that break-even point, your entire perspective shifts, and the goal becomes all about maximizing your total revenue.
Now take a look at this linear demand curve. The basic principle is simple. Demand for a product is directly related to its price. Lower the price, and demand goes up. You sell more units. But you know, that straight line really doesn't tell the whole profit story. Total revenue isn't just demand, it's price multiplied by demand. Because total revenue is a product of price and demand, the curve arches into a parabola. As you lower the price, demand goes up, and your revenue climbs. But eventually, you drop the price so low that even with massive demand, your total revenue just starts falling off a cliff. Our absolute goal as estimators is to find the peak of that arch, the exact sweet spot before revenue starts dropping again. That is where maximum total revenue lives.
Section 5. The art of estimation. Design optimization. To consistently hit that maximum profit peak, engineers have to rely on cost-driven design optimization.
This optimization involves a really strict four-step process. First, you identify your primary cost driver variable. Once you have that locked in, step 2 is expressing your cost model entirely in terms of that specific variable. From there, for continuous functions, you step into the calculus to differentiate the function, and finally, step 4, you solve that equation to find the mathematically proven value that minimizes your total cost.
Let's apply this to a real-world copper wire design. We're trying to find the minimum annual equivalent cost, which is just the sum of your capital cost and operating cost. Think about it. As the cross-sectional area of the copper gets bigger, your capital cost goes up because you're buying more material. But your operating cost actually goes down because a thicker wire wastes a lot less energy. By expressing this as a cost model and calculating the derivative to find exactly where it equals 0, we discover the mathematically perfect lowest cost cross-sectional area. In this specific case, it's 5.276 square inches. It perfectly balances your capital expenditure right against your operating efficiency.
So, as we wrap up this explainer on cost concepts and design economics, I want to leave you with one final thought. We've seen exactly how precise cost-volume analysis and optimal design variables drive true profitability. So, when you're making your next major business decision, are you going to let cold, optimized math lead the way, or are you going to let the ghost of sunk costs completely ruin your profit margins? Thanks for exploring this module with me, and I'll catch you in the next one.